Well, hello and welcome back. In this video, I'm going to talk about the mathematics of learning curves. I sort of give you some example questions, refer you back to the Introduction to Learning Curves video. If you haven't looked at that already, it's worth taking a quick look just to understand the concept. This one, we're going to go through some sample questions that you could see if you were taking an operations management course and there were assignments, quizzes, or exams. So we're going to go through some of the types of questions you could see. Let's just review quickly the mathematics of learning curves. There are three ways. There's the arithmetic analysis, where it only works for 1, 2, 4, 8, 16, 32 for the number of times that you've doubled. So you've got Tn here is the nth unit, is the time that it takes the first unit, times the learning rate to the number of times doubled. This is something that students often get wrong. They'll often put the 4 up there, and that's incorrect. It is the number of times doubled. So at 2, it's doubled once. At 4, it's doubled twice. At 8, it's doubled 3 times. So that's where that goes in. Relatively straightforward. It is probably the easiest approach there, but it only works for those numbers that are on the path of the doubling. The next approach is the logarithmic, where you have the time for the big N, the nth unit, is T1 times n, which is this time that unit, times b, where b is equal to the log of the learning rate divided by the log of 2. I usually calculate that separately. And if you go back to the next system, the coefficients, where you pick a table, and in this circumstance, you've got, I'm just making sure we're still recording here. Yeah, we're still recording nicely. The table will calculate NB for you. So the nice thing is, if you have a table that looks like this, you don't have to calculate. And so in this case, you've got the unit numbers down here. You have up here the learning rates. Most textbooks that teach learning rates will have these. And you look at the number and you've got the coefficient here. The nice thing about about the coefficient is you also have the total time coefficient on the table here, where you have the total to make that number of units. So the first column is to make the fifth unit is 0.437 times the first unit, and to make all 5, it's 3.195 times all of those units. So the nice thing about the coefficient table is it gives you that total as well. In the absence of that, you would have to calculate each number and then add them up. So let's do a simple example. I'm going to just check that, yeah, we're still recording, and I can see you can see the numbers reasonably well. So here are the basic parameters. T1 is equal to 40 hours. L is equal to 85%, the learning rate. So let's say the first question is, how long will the second unit take? And the second unit is T1, T2 is equal to T1 times the learning rate, right? Because this is doubled once, so it's the learning rate to the first power, which is the learning rate, is equal to 40 times 0.85 equals 34 hours. So the second unit would take 34 hours. Third unit we're going to have to use the log approach or the coefficient approach, because it's not on that regular path for doubling, so we can't use the arithmetic approach. So we've got T3 is equal to T1 times 3 to the b, where b is equal to the log of the learning rate divided by the log of 2 is equal to negative 0.2345. Now, you could calculate this whole thing at once if you want. I will usually calculate b out separately so I don't make a mistake on my calculator, and I then also can reuse it. If you're going to do it all at once, make sure you use brackets for this b so that you don't make an error, and it's very easy to go wrong there. So I would usually always calculate it separately. So now we got T3 is equal to 40 times 3 to the negative 0.2345 is equal to 30.92. And if you were to use the coefficient approach, we get T3 is equal to T1 times the coefficient at 85% for 3 is equal to 40 times, and we're going to go to this table, look at 85% and at 4. We are going to get at 3 we're going to get 0.773. So at 3 we would get 0.773. 0.773 is equal to 30.92. 3 to the negative 2.345 is equal to 0.773. So essentially, it's giving you the doing that calculation on your behalf. So C, fourth unit. If we use the arithmetic approach, we would get T4 is equal to T1 times L squared is equal to 40 times 0.85 squared is equal to 28.92. I'd also highlight here that it's also equal to T2 times L, because T1 times L is T2, and you'd get the same answer. On the coefficient approach, T4 is equal to T1 times485 is equal to 40 times, and I would go back to the table here, under 85, 4 is 0.723, and I get the same answer as I would expect. It's also worth noting that the numbers are still going down. If they're not going down, you're doing it incorrectly, but they're going down at a decreasing rate. And finally, the logarithmic approach, T4 is equal to 40 times 4 to the negative 0.2345 is equal to 40 times 0.723 is equal to 28.92. So even if you're using the table, I would practice using the logarithmic approach and use the table to double check your work, because invariably someone is going to ask you a question for, say, 23 that's not on your table, and if you can't do it, then you're going to run into trouble. So let's go. How long for the 20th unit, T20 is equal to T1 times C20, 0.85 is equal to 40 times, back to the table here, look at 20, and we get 0.495. And the log approach would be the same. T20 equals T1 times 20 to the negative 0.2345 equals 19.8. So the approaches should give you the same answer every time. Now, consider if we're asked for the total time for 20. For 20, and in that case we could do T20, T19, T18, blah, all the way back, and that wouldn't be a really super productive use of your time. So we're going to, in that case, equal T1 times the coefficient 20 for the total 0.85, and we're going to go back to our table here, and 20, and now we're looking for the total time coefficient, and we have 12.402. So we look 85%, 20, and in the total column, and there we go, equals 40 times 12.402 equals 496.08 hours. And F, percent increase in productivity from T1 to T20. And if you remember, this is where we tie things together. Productivity is a measure of output over input. So we have 1 unit. So this is the productivity for the first. 1 unit over 40 minutes or 40 hours equals 0.025 units per hour. Productivity for the 20th is equal to 1 over 19.8 is equal to 0.051 units per hour. And the percent change is equal to the P20 minus P1 over P1, because we always go from where we start, is equal to 0.051 minus 0.025 divided by 0.025 is equal to 104%. So we've improved our productivity by 104% from the first unit to the 20th unit. So that's sort of the basic execution of learning rates with all 3 tools is relatively straightforward, I would argue. So there are some other things that you could get asked, or some nuance you could get asked across these questions. So let's just do that. Question 2. Yes. So the first unit took 100 hours, and the 4th unit took 81 hours. What is the learning rate? Now, the temptation would be just to put 81 over 100, but that would only work if the second unit took 81 hours. So this is really just testing that you understand the system or the formula, and because we know the 4th is on that doubling path, we can use the arithmetic approach. So T4 is equal to T1 times L squared, because we double twice to get to 4. So 81 is equal to 100 times L squared. 0.81 by taking this over to that side is equal to L squared, take the square roots of both sides, and you've got a learning rate of 0.9 or 90%. Relatively straightforward, just trying to make sure you understand how it goes from one to the other. And just to highlight another new concept, the improvement rate. This is really the only trick an instructor can throw at you is giving you an improvement rate rather than a learning rate. That's something to watch for. The improvement rate is 1 minus the learning rate, so is 1 minus 0.9 is equal to 0.1 or 10%. Again, relatively straightforward, is really just one trick that it can throw at you. You could have done this with the coefficient approach or the log approach, but hopefully no instructor will be cruel enough to ask you to calculate in an exam using the log approach, where you have to go the anti-log and it would just be longer. You could actually use the coefficient approach, where then you would calculate the coefficient and look through the table for the 4th unit and find the learning rate that works. That would work as well. And I can show you an example of that, relatively straightforward if you'd like. So 3, new product intro. Second unit, took 1,000 hours. What is the learning rate? Now, in this case, we have the 2nd unit and the 4th unit, so we could use the arithmetic approach. For T4 is equal to T1 times L squared, which is also equal to, if I expand that, T1 times L, which is L squared. T2 is equal to T1 times L. So T4 is equal to T2 times L. So 750 is equal to 1,000 times L. So L is equal to 0.75 or 75%. Again, this question really just testing to see that you understand the equations for the arithmetic approach or the coefficient approach. So let's do 3 more sort of alternative questions that you could get asked here. So you have 100 hours to make first unit after the 2nd and 3rd units were made. We estimated was 80%. Now usually we would use a larger sample than 3, but this gives us a place to start here. At $25 per hour, estimate the labor bill for the 4th unit and for all 4 units. So T1 is equal to 100, L is equal to 80%. Again, we could use the coefficient or the log approach. We're on the path of the doubling, so we're just going to use the arithmetic approach here. T4 is equal to T1 times L squared is equal to 100 times 0.80 squared is equal to 64 hours. The labor bill is 64 times $25 equals $1,600. For the total, we could go calculate T1. Well, we have T1. We could calculate T2 and T3. We've got T4. I'm going to go back to the coefficient table. Coefficient 4, total 0.80 is equal to, go on to here, 80% for 3.142. For the total time coefficient equals 3.142. Total time for 4 equals 100 times 3.142 is equal to 314.2. So then total labor is equal to 314.2 hours times 25 per hour equals $7,855. So there's a simple question: how much would labor cost, and a simple way to calculate them. So quickly do 2 more examples. Two products where T1 is the same product A has an improvement rate of 10%, product B has an improvement rate of 20%. How much longer will it take to make the 10th unit of A compared to B? We know that the improvement rate is lower for A, and so that B is going to improve more quickly. So we get a coefficient. We can So we could do the log approach because we have the learning rates, and we know N and we know B, so we could, but we're going to just go to the table for N is for 80% and 90%. So C1090 is equal to 0.705. I can show you that. C1090, 0.705 right there. C1080 is equal to 0.477 right there. C1080 is equal to 0.477. Now, I didn't give you T1, so are you stuck here and you can't go any further? The answer is no, because if you're looking at percentage improvement, you would have the time to make the 10th unit at 90 minus the time to make the 10th unit at 80 divided by the time to make the 10th unit at 80. And you look here, we can simply cancel the T1s in the formula and then just use the coefficients, where we would get 0.705 minus 0.477 divided by 0.477 equals 0.48 is equal to a 48% improvement. So, and again, it is just understanding the formulas and being able to do that simple algebra. That is my last example. Just then to review, relatively straightforward. 3 approaches. Arithmetic. 1, 2, 4, 8, 16, and so on. Logarithmic and the coefficient. It's worth learning all 3. The only thing you need to really watch out for is the improvement rate is 1 minus the learning rate, and otherwise there are no tricks that an instructor can throw at you here. So that's it for learning rates. Good luck.